Hey everyone, and welcome back to News About Geology. I'm your host, Ricardo Valls. Today, we're putting on our detective hats because we're going to uncover the secret life of a single data point. I mean, seriously, think about it for a second. We make huge decisions about mineral resources, about cleaning up the environment, all based on these little numbers in a report. But how do we know we can trust them? How can we be sure that number isn't an imposter? Well, that's the mystery we're going to solve today. And let me tell you, the stakes are incredibly high. Every model we build, every conclusion we draw, it all rests on the integrity of our data. You see, that single number isn't just a number. It's really the final chapter in a long, meticulous story of investigation, a process designed to make sure what we think we know is actually true. Now, to solve this mystery, every good detective needs a toolkit, and ours is called QA/QC. Just think of quality assurance, the QA part, as the overall game plan, the grand strategy. Then you've got quality control, QC, and those are the routine, on-the-ground checks we do every single step of the way. Together, they are the absolute backbone of trustworthy science. So here's our investigative roadmap. First, we're going to open the case file on trusting data. Then we'll secure the scene against some invisible enemies. After that, it's interrogation time for the data itself. And finally, we'll deliver the verdict with a full-on laboratory audit. All right, let's open the case file. The very first thing we have to accept is that no measurement is ever perfect. Every single one comes with some degree of uncertainty, and our job is to understand just how much. Okay, now we're heading to the scene of the crime, so to speak. And our main job here is to fight off invisible contamination. Securing this evidence right from the very beginning is absolutely crucial. Contamination is like this invisible villain. And get this, this is wild. Up to 70% of QC mistakes can happen before a sample ever even sees the inside of a lab. We're talking about things like weathering on a rock, a little bit of grease from a drill, putting it in the wrong kind of bag, even dust from a really high-grade sample that was processed earlier can ruin a whole batch. Every single step is a potential booby trap. So how do we stand guard against this threat? We use a kind of sentinel, a tool we call a blank. Basically, it's a material like pure quartz sand that we know has zero of the element we're looking for. We sneak it into the sample lineup, and if it comes back from the lab showing any trace of our target element, bam, we know we've got a contamination problem somewhere. It's our early warning system. You know, the best labs are almost fanatical about cleanliness. I remember a colleague of mine was visiting a lab I was running, and he just looked around and said, "You can eat from the floor in this place." And that is exactly the standard you want. Here's a little trick I always use when I visit a lab. I take out my phone, turn on the flash, and snap a picture of the air. If there's any dust floating around, the flash will light it right up, revealing invisible culprits. All right, our evidence is secure. Now comes the intense part, the interrogation. We have to question the data itself to find out if it's both accurate and precise. In other words, is it correct? And can we get the same answer over and over again? And this is just a brilliant way to picture the difference. Accuracy is all about hitting the bullseye. Is our measurement close to the real, true value? Precision, on the other hand, is about how tight your shot group is. Are your measurements all clustered together? You see, you can be really precise, but completely miss the target. For data we can actually build on, we need both. So, how do we test for accuracy? How do we know where the bullseye is? We use what's called a certified reference material, or CRM. Think of it as the ultimate ruler. It's a sample that has been analyzed by tons of labs all over the world, so it has a known, certified, true value. We send it to our lab, and if their result matches that certified value, we know their measurements are on target. And for precision, for that, we use duplicates. This is where we take a single sample and split it at different stages, maybe right in the field, or after it's been crushed, or after it's ground into a fine powder. We then analyze these splits like they're totally different samples. If the results are nearly identical, we know our process is consistent and repeatable. Hey, just jumping in for a second, if you're finding this geological detective work as cool as I do, I really think you'll enjoy the other deep dives we do on my YouTube channel. Just search for p.geo.ricardo.valls on YouTube. I'd love to see you there. All right, we're in the home stretch now. It is time for the final verdict, and that comes from the laboratory audit. This is where we put the entire system on trial, not just one piece of the puzzle. But that brings up a really big question, doesn't it? I mean, how do you verify everything all at once? The people, The written procedures, the maintenance on the machines, the paperwork, the whole shebang. How do you do that? The key, really, is having the right mindset. A good audit isn't about trying to catch people doing something wrong. It's a team effort. The auditor's attitude should be, I am here for you to show me that you do it just right. It's about building a partnership to make sure you get the best data possible. And when I say a thorough audit checks everything, I mean everything. They look at the written procedures, the SOPs, and make sure they're being followed. They check staff training records. They go through the maintenance logs for all the instruments. They trace the sample's entire journey, what we call the chain of custody. They check data management, and they make sure the lab is following international standards, like ISO 17025. It is a complete, top-to-bottom, physical. And that's what it all comes down to, really. The audit confirms that the entire ecosystem that created our data point is healthy and functioning correctly. It's the final step that gives us that real, verifiable confidence in the numbers we have to rely on. So the next time you see a data point in a report, remember its secret life. That number didn't just appear out of nowhere. It's the headline of a long, detailed story, a story of fighting contamination, of intense interrogation, and of rigorous verification. It's a story written in the language of QA/QC. To keep exploring all the fascinating stories our planet has to tell, please visit my YouTube channel. You can even scan the code right there on your screen. Thanks so much for watching News About Geology.